Hello again, Algebra 2 class. In this video series, we'll be discussing logarithmic functions. This is Chapter 4, Section 3 in your Algebra 2 textbook, and our primary objectives are going to be to convert between exponential and logarithmic form, evaluate logarithmic expressions, and graph logarithmic expressions. The first thing we want to discuss in these videos is what exactly is a logarithm. If you remember back in Chapter 4, Section 1, which was on exponential functions, we had mentioned that we didn't know how, at least using algebra, to solve for an unknown in an exponent. Well, logarithms are the tool that let us solve for that unknown exponent. A logarithm is the exponent to which a base must be raised to obtain a given value. Now, another thing about this is a logarithmic function is the inverse function of an exponential function. In other words, logs undo exponents. So in this specific case, we could say that log base 2 of 8 equals x. Because remember, the answer to a logarithm is always just the exponent of the exponential function. Now we can generalize this a little more and just use all general terms. So if we have any exponential equation, b to the x equals a, we can rewrite that as log base b of a equals x. Now there are a couple things to point out here. Just like above, the log equals the exponent. That's a big one. That should help you remember how this formatting goes, that the log equals the exponent. Another thing to remember is that the base of your exponential function is the same as the base of your logarithmic function. Now remembering where that last piece goes can be a little tricky, but if you filled in the other two, there's really only one spot left for it to go. Which brings us to kind of our skill for this video, which is converting between the two forms. Right? We want to be able to convert between exponential and the logarithmic form for any equation. So if we fill in this table, that'll give us a few practice problems to look at. We start with the exponential equation 2 to the 6th equals 64. Well, I know that my base on this exponential equation is 2, so the base of my log must also be 2. And I know that my log always equals the exponent, so this must equal 6 because that's the exponent. So that means that log base 2 of 64, and the only place left for 64 to go, is 6, which in other words means that 2 to the 6th power equals 64, which is exactly what we had over here. Well, we can fill the same thing in over here. 4 to the 1st equals 4, so log, keep the same base, so log base 4, and I know that my logarithm has to equal the exponent, so equals 1, and that leaves only one spot left for the other 4. So log base 4 of 4 equals 1. Now we can also go the other way. Well, log base 5 of 1 equals 0. My base has to be 5 on my exponential equation, and I know that my log equals the exponent, so 5 to the 0 equals 1. Which, if you remember our exponent rules, that should make sense because anything to the 0th power equals 1. Going back the other direction, 5 to the negative 2 equals 0.04. Well, again, the logs are going to be the same, so log base 5. And I know that my log has to equal the exponent, so equals negative 2. And so I'm going to see log base 5 of 0.04. Brings us to our last example. Again, log base 3 of 81 equals x. This one we have a variable thrown in, but it still works the same exact way. My base must be the same, so 3. And I know that the log equals the exponent, so 3 to the x equals 81.